Okay, topic 7. We're going to just go through and review all the lessons we've done so far. This one will be as of the time you're actually going to watch this later after break, okay? So, lesson 7.1, we were adding and subtracting polynomials. We made the 2 posters on the wall where we defined what a polynomial is, talked about how we can have 2 terms, which makes a binomial, 3 terms makes a trinomial, and just 1 term is a monomial. And then we needed to look at how do we simplify them by adding and subtracting with them. What did we need to do different if we were subtracting polynomials versus adding them? Peyton.
You distribute the negative to like each term in the bottom.
Right. You got to distribute the negative because you're no longer just subtracting one number from a number, right? It's several terms. So you have to change all of those terms to their opposite. Okay, so let's get an example of an addition problem and one of the subtraction. Peyton, what do you got?
5x squared minus 4x plus 3, and then add 3x squared.
Oh, forgot the plus sign. That's a big difference. 3x squared
Plus 2x
plus 2x
minus 4.
minus 4. And so really we're just looking and combining like terms, and I don't have a lot of space, so I don't really want to write the answer, but where could I write the answer? I don't know where I could write the answer. I'd rather look at a subtraction one because I think that one was more simple. So somebody else give me a subtraction problem. That?
The subtraction problem?
Yeah.
Oh. 3 minus 2x plus 2x squared minus
3 minus 2x plus 2x squared
minus 5x minus 4x minus 3x squared.
So clearly those are not written in standard form. That was the other thing we learned, right? Was how to write them in standard form. Your final answer should always be highest degree to lowest, or highest exponent to lowest, okay? So this is the situation where we would literally need to go through and rewrite this, where if it was a positive, it's now negative, and if it was a negative, it's now positive, and then combine like terms. Okay, next lesson we did was multiplying polynomials. And so give me an example of that. Somebody different, please. Dylan.
6x minus.
Is this a binomial, or is this just a, okay.
Yeah.
Okay, keep going.
X squared minus 4x minus 3.
Okay, so in this case, we're just showing our rainbows, our arrows, whatever you want to call them, and we're making sure we multiply every term. In the front set, the monomial times every term in the trinomial. Same thing if we were to have 2 binomials. We would need to make sure that this is the one that we got to FOIL, remember? F-O-I-L. There was 4 terms total, multiplied, so 2 binomials. And you needed to FOIL, so you did your fronts, your outers, your inners, and your last ones, F-O-I-L. Okay, how about a special case? What was an example of a special case when we were multiplying? It's not a race. I'd rather hear from somebody different. Somebody new.
Wouldn't it be like x minus 5 times x plus 5?
Yes. Good job, Melissa. A sum and a difference, right? Sum and a difference. There was looked like the same exact binomial, but one was adding, one was subtracting. And what happens when we multiply that out? What was that called? Difference.
Difference of squares.
Difference of squares. Difference of squares. Because our inners, our terms with just x, canceled out. And so we were left with our front and our last, which is x squared and then minus 25. Where are the squares in that binomial answer?
X is squared and then negative 25 can be 5 squared.
Well, yeah. Exactly. X squared is a perfect square, 25 is a perfect square, and then you have the difference, so that gives you the subtraction in the middle. Okay? How about factoring with greatest common factor? Landon.
12x to the power 5 plus 8x to the power 4 minus 6x cubed.
Oh, okay. I was like, are we going to go all the way down to the power of 0? Because that's going to be a long one. All right, so they all share, so first we looked at the coefficients. Do they have a greatest common factor?
Yeah.
Yeah. What is it? 2. Okay, so we can pull out a 2. And do they all have variable?
Yeah.
What's the least amount that they all share?
3.
Or the greatest amount, sorry. 3. So you can pull out 2x cubed. And then what do we need as our product in order to get back to the original? We would need 6x squared
4x.
minus 3. Good. Factor by grouping. That's the one I'm going to check here in a second. So you could give me an example off of that or off of the video notes that you have. Factor by grouping, we learned this. How many terms are in the polynomial when we do factor by grouping? 4. 4, yeah, so it's not a trinomial. It's just labeled as a polynomial. Okay. Somebody different? Gabby.
X squared plus 6x minus 16.
Is there another thing that we have?
I don't think so. And then she was the parentheses and x plus 8 parentheses and the x minus 2. I got that off your video.
That may have been a different lesson.
Oh wait, that was 7.5, sorry.
7.5. Okay. Do you have one for 7.4? Okay.
X and then 2 plus 7x squared plus 2x plus 14.
Okay, nice. 4 terms. And so what did we do here? Split them into 2 binomials. So we get the fronts and the last ones, okay? And then
You find the GCF of the first one.
pull out the GCF. They both share x squared at most. So pull out x squared. We would need an x plus 7. Over here, we can pull out a 2. And so here's what I noticed, that people were just writing a number with no symbol in between. It's important to put the symbol there because you may need it to be a negative or a positive, and you don't want to always assume that it's a positive, and so then you'll factor it in correctly, okay? So it will be a positive 2, so make sure you put that there when you put your GCF, the second one. And then you need x plus 7. Hey, look, we got the same one right here. So now factor that out. And x plus 7. What's left? X squared plus 2. I feel like those are my favorite ones to do. Do you like those too? Yeah. Okay, factoring quadratics, something that should have been started yesterday. Who's got some info? Isaiah, you got it?
Yeah.
Can you share an example with us, please? This is when a equals 1. Do I have space? Let's see. I'm just going to write our quadratic formula here on the side. Okay.
M squared SM minus 90.
M squared plus M minus 90. Okay. What do we do? Does it have a greatest common factor other than 1? Well, we're not doing that method then, are we? What did we do on that one, Isaiah? Was that from the video?
What? No, it's not.
From the worksheet?
Yeah.
So are you not sure what to do because you haven't checked the worksheet? Or... We need to think, what two numbers will multiply to give us negative 90, but also give us a sum of 1, because there's a 1 as a coefficient here. So B is 1 and C is negative 90. Dylan? Well, I don't know which one is it. We need a positive one.
10 and negative 9.
10 and negative 9 would multiply to give us negative 90, and would add up. 10 plus negative 9 would give us 1. Okay? So what we do is we set up our two sets of brackets, because we're going to do two binomials. We know that we need m times m to give us m squared, right? Remember in FOIL, that's our front number. And then we need a positive 10 and a negative 9 to give us a C value of negative 90, our last, but also 10m plus negative 9m gives us 1m. This is what we do when a equals 1. So when you don't see a coefficient written, you know the coefficient is 1. That means a equals 1. And then the next lesson is when a does not equal 1. And we're going to have to pause that one and do that. I'll have to finish that later because I don't even think I have enough space. Okay, so this last lesson that's on our list is factoring quadratics when a is greater than 1. And sometimes we may have some where even though a is greater than 1, we can still pull out a greatest common factor other than 1, and then continue to factor that way and maybe do some factor by grouping after. But in a lot of cases, the only greatest common factor of a situation like this is just a 1. And so we need a different method. So this is where we're going to use the magic X method. And this is the method where we take our A value and multiply it by C for the top number. And then our B value goes down here at the bottom. And we're looking for a number, if we look over here, that is going to, just like here, multiply to give us C and add to give us B, add or subtract, depending on if they're positive or negative. So let's use this one as an example. 3x squared minus 8x plus 4. And so we're going to take A and multiply it times C, and that's going to give us our value for the top of the x, which is 12. And then our B value is negative 8. So we're looking for two numbers that will multiply to give us 12 and can be added, put together to give us -8. So I know it can't be 3 and 4, so now I'm thinking 6 and 2. Well, I need a positive 12 and -8 when I combine them, which means I must need -6 and -2. Multiplied will give me a positive, and put them together it gives me a -8. So now we come over here and we're going to rewrite this polynomial, and instead of writing -8x, we're going to split it into -6x and -2x. Now we can take this, which has 4 terms, and we can use grouping to factor this out. Greatest common factor here is 3x. We would need an x minus 2 to get 3x squared minus 6x. Over here, greatest common factor is 2, and we would need, oh, you know what? We need negative. We need a -2 because we need a positive x inside here. -2, so we would need an x minus 2 to give us positive 4. So now we have our another greatest common factor, x minus 2, of all of this. And then what we have left is 3x minus 2. And so that is a review of how to work with polynomials from lesson 7.1 to 7.6.